All right, last time we were talking about tension, and now we're going to talk about tension, but we're going to bring in pulley systems. We're going to draw the forces acting on this pulley and mass system. So under mass 1, we've got the force due to gravity. Under mass 2, we have the force due to gravity 2. And then we have tension and tension. Okay? So we have this problem, and it's kind of difficult to figure out which forces to add and to subtract in your F-net formula just because of the orientation of the system. But we have a solution, have a way to make this easier for you. So what we're going to do is we're going to unfold it. We're going to unfold this pulley system. We're going to pretend like we've got our pulley here and our two blocks, and we're going to pretend like we're unfolding it up this way. And we're going to move our forces so that they are kind of bent this way. So we've got force due to gravity 2 going this way now. Force due to gravity 1. And then we have our two tensions. So now this looks a lot like the cart problem that we did in our tension practice. So everything is in the same plane, and it's a lot easier to figure out which way this pulley system is going to move once we know the masses. I'm going to erase that here. We'll move on to an example. So key thing to remember again is that when you're solving for the acceleration of the whole system, use the total mass. When you're solving for tension, use only one mass. So here's our example. We've got two masses hanging on a frictionless pulley, and they're initially at rest. But you can see these two masses, they're different sizes. We've got one that's 6 kilograms, and we have one that's 4 kilograms. So it's pretty clear that if you let go of this pulley system, it's going to accelerate. So it's going to accelerate toward that heavier mass. Anybody that's played with a scale or balancing anything, the heavier side is gonna win that one. So we want to figure out what the acceleration of that system is going to be. It's not going to be exactly the same as gravity because we have that other mass being pulled by gravity on the opposite side. So it can't be 9.8, even though the thing is falling. So we're going to find the acceleration, and then we're going to find the tension in the string. So again, we're going to unfold this pulley system. So we have FG1, FG2, tension, tension. Okay, so we're going to unfold this pulley system. And now we have FG2, tension, tension, and we have FG1. So the pulling force here is due to gravity. Okay, so to find our acceleration, we need our net force equation, F equals ma. And remember, this is the total mass, not just the mass of one of these. And we're looking for the acceleration. So acceleration is equal to F over m total. So the F net, or the sum of our forces, divided by the total mass. Okay, so if we're looking at the sum of our forces, A equals the sum of our forces, we have force due to gravity 1 minus force due to gravity 2. And again, you can put these in any order that you would like. If you want to define FG2 as your positive side, that is fine to do. I usually like to go with the thing that's bigger. But again, if you want to be more consistent for you and go with the right side, just like we did with projectile motion, you can do that. Again, our tensions cancel, so we don't really need to have that in our net force equation. So we've got those two divided by our total mass, which is 6 kilograms plus 4 kilograms. So we've got divided by 10 kilograms. Okay, now you're saying, I don't have gravity 1 and I don't have gravity 2. I don't have those forces. What do you expect me to do? Well, you do have those forces. You just have to calculate them. So remember, the force due to gravity is equal to the mass times the acceleration due to gravity. So Fg1 is really 6 times 9.8, and Fg2 is 4 times 9.8. So if we do 6 times 9.8, we get 58.8, and we're going to subtract that from 4 times 9.8, and that gives us 19.6 newtons divided by the 10 kilograms. And that leaves us with an acceleration of 1.96 meters per second squared. So that's your acceleration, okay? So 1.96 meters per second squared. I'm going to go ahead and erase this so we can find the tension in the string. 1.96 meters per second squared is our acceleration. Okay, now we're looking for the tension. Remember, we need to use one mass, not both, in order to find the tension. So we're going to look at the sum of the forces acting on, let's see, mass 2. Okay, so that would be equal to mass 2 times the acceleration of the system. And the sum of the forces on mass 2 is going to be equal to F2 minus tension. So F2 minus tension is equal to M2 times the acceleration. So tension, if you go ahead and solve this, you've got mass 2, which is 6, times the acceleration we just found, 11.76. And then that force, remember, is the force due to gravity. So we had 9.8 times 6. So our tension should be 47 newtons. Okay, so that's pulleys. Again, they're not bad so long as you remember to flip them. Okay, I've got some homework posted for you in Classroom. Go ahead and take a look at that and let me know if you have any issues. That's all I've got. Bye.